Right, part A is simply a case of looking in the normal distribution tables for a z value of 0.5. Because the normal distribution tables give us the area to the left of a z value, in other words, the probability that it is less than whatever our z value is, then that's why we just need to look straight in the tables for 0.5 on z. So we're down to 0.5 and the first number we have is 0.69146. So 0.69146. B, this time we have greater than, so we can't just go looking in the table straight away. We need to think about this. But let's use this diagram to figure out what we're going to do. 1.66 will be about there, and we would like the area to the right. Now the table gives us the area to the left of 1.66, and we want the area to the right. So we're going to need to do one takeaway, the probability that z is smaller than 1.66. So that's one takeaway. So let's look at 1.66. So down to 1.6 on the left, and then across until we're under the 0.06 column, and we have 0.95194. 0.95154, and when you take that away from 1, 0.04846. In part C, here the problem is we have a negative z value. So less than minus 0.5. Negative z values don't show up in the table, so we need to use the symmetry of the table to help us get around this. Just kind of clear that. So minus 0.5 will be about there. And we would like the area to the left because it's less than minus 0.5. Now we can look in the table and get the value for positive a half. And the table will give us the area to the left of positive a half, which will not be the same as what we're trying to find here. So the area I've shaded in is the area we want, which is the same as this area. But the table doesn't give us the right hand side. The table gives us the area to the left. So first of all I'm going to write that the left shaded area, which is what the question is asking for, is the same as the right hand shaded area. So I'm going to put the 0.5 there. So that's this right hand area, greater than 0.5. I'm a bit better off now because I've got a positive z value. And now I can look in the table. And remember, I want the area to the right. Sorry. Yes, I want the area to the right of a half. But the table will give me the area to the left. So I'm going to need to do 1 minus the value from the table. And the table gives you the area to the left for the less than. And that's actually what we found in part A. So it's 1 minus 0.69146, which is 0.30854. In part D, it's a bit of a combination of B and C. We've got greater than, and we've got a negative z value. So how should we deal with these? Well, let's look at the diagram. Minus 2.6 will be about there, and the greater than tells me I want the area to the right of minus 2.6. So the total area to the right, using the symmetry of the normal distribution curve, hopefully you can see that will be exactly the same area as the area to the left of positive 2.6. Will be exact same area. So the probability z is greater than minus 2.6 is the same as the probability z is smaller than positive 2.6. So we just need to look in the table for 2.6, which is 0.99534. So 0.9954. In part E, we have the area between two values. So we need the area between 1.24, which would be about there, and 2.36, which would be about there. So it's that little strip there. To do this, I'm going to look in the tables for the area to the left of the larger number, 2.36. I'm going to subtract the area to the left of the smaller number. So what we'll be getting there is everything to the left of 2.36. That's all this. And then I'm going to get rid of this unshaded area here. And that's everything to the left of 1.24. So the values we need are 2.36, which will be there, 0.99086, and 1.24, which is that one, 0.89251. Which, if you subtract those, you get 0.09835. In part F, this is the area we're trying to find between minus 1.23 and 1.89. So I'm going to look in the tables for a z value of 1.89, and that will give me everything to the left of 1.89. Now obviously that includes this little unshaded area, which we don't want, so we're going to need to take that off. So what I need to do, the probability z is less than 1.89, so that's everything to the left of 1.89, but then take off everything less than minus 1.23. I can look at 1.89 straight away. So 1.8, go all the way across to 9, 0.97062, but then the other bit I can't look straight in the tables because it's a negative z value. But remember how we dealt with that in part C? We ended up doing 1 minus the equivalent positive z value. So in C we had negative 0.5. We simply did 1 minus the probability of positive 0.5. So here I'm just going to do 1 minus the probability z is less than positive 1.23. So looking in the table, 1.23, 0.89065, and when you work that out, we get 0.86127.